Welcome back to Little Bang Discovery Plus. Our last session was about light. We'd be having a science fair now about that if we were face to face. If you haven't had a chance to talk to your grown-up about what you learnt, or if there's something new you want to discuss, then now's the time. Have a little chat about light and what we did last time. Now this session is all about wonderful water and measuring accurately. So we're going to ask you, first of all, what do you think you already know about water? So here are some questions and you can have a chat with your grown-up. Just remember, let the kids have time to think, and it doesn't matter if they're not completely correct, because we're going to do some learning and some testing and their ideas might change. So the first question is, when do you use water? And that might take quite a long time to answer. So grown-ups, if you would like to write down what the children say about when they use water. The next question is, do you know what it's called when it's a solid? What do you call water when it goes hard? And the last question is, can you mix things in water? And we'll be testing that question in this session. Okay, so the first thing we're going to do is do some accurate measuring, because that's what we're about today as well. So we need your measuring cup from your discovery box. We need your pipette, if you've managed to get hold of one of them, or your eyedropper, or your straw. So these three things can be used interchangeably. So if you've just got a straw, that's fine, you can use that. Excuse me. And we're also going to use the syringes, if you've managed to get hold of some syringes, or if you've got one from the medicine. The children's medicine often come with a syringe because you can measure very accurately with them. So what I'd like you to do first of all is to pour some water into your measuring cup, doesn't matter how much to start off with, and have a go with these things. So the pipette, you squeeze it and the air comes out, and then the water gets sucked up, and then you can put tiny little drips in. So you can put in just a tiny little drip, and you might see your pipette has got gradations down the side to say how many mils it has. Likewise with the eyedropper, if you squeeze it, the air comes out, the water goes up into it, and then you can just drop one drop at a time. So this is a very accurate way to measure how much water you're putting into something. And then the straw can be used in a similar way. If you put the straw in, and then you put your finger on the top, and then you can get just one drip coming out at a time. So you can use a straw to measure very accurately too, and then when it slows down you can take your finger off and the last of the drips will come out. Now with the syringe, I need two hands for this. So the syringe has got numbers on the side again to show you how much you're taking in, and then when you pull the syringe up, then it fills up with water, and where the bottom of the black line is the number, how many mils is in there. So at the moment I've got 10 mils in there, and then I can squeeze it and put in and get 9 mils, squeeze it a bit more and I'll get 8 mils, and can you see how much water is coming out as I squeeze down another mil? It's a really small amount. So syringes can measure very accurately, and it's similar with your measure for your medicine. So as you pull the top up, now I've almost got, so when the bottom of the orange bit sits right on the 2.5 mil line, that means I've got 2.5 mils of water in my medicine measuring syringe. Okay, so what I'd like you to do now is have a play with whatever things you've got and see which one you like the best to measure accurately with. Which one do you find the easiest to use? So have a little bit of a play, measuring water very accurately. Now that you've had a practice at measuring water accurately, we're going to try and get 150 mils exactly in our measuring cup. So at the moment, I've got a bit more. I think I might use my syringe to suck some out so that the water goes down. Okay, it hasn't gone down quite far enough, so I'll put that spare water in there and try again. Take some more out. Oh, getting close now. So when I hold it up at eye level, my water line is very close to the 150 mils. I'm just going to take out a little bit more, and I'm actually going to bob down so that I can see right where that line is and now it's just about spot on the 150 mil mark. So now that I've got my 150 mils of water, I'm going to pour it into one of these plastic cups. Now, for our next experiment, you need 6 cups with 150 mils of water in, and making it as accurate as you can so that for each cup it's exactly the same amount of water to make the test fair. So I'm going to do that now, and you can probably pause the video while you do that too. So 6 cups, each with 150 mils of water in it. So this next experiment is what dissolves. And we're going to be using things probably from your pantry to try and answer that question. Now, before we do the experiment though, before we actually test, we're going to have a guess, make a prediction to see if we think the thing will dissolve. So you should have your 6 cups of 150 mils measured very accurately of water. And I've got some things here that I'm going to use to see what dissolves. And the other thing that we need to do is we need to make sure that we put in exactly the same amount of each item so that it's a fair test, because if you put in a lot more of something compared to something else, it wouldn't be a very fair test. Now, the things I'm going to use some Nesquick, I'm going to use some Milo, I'm going to use some sand, I'm going to use some sugar, I'm going to use a piece of polystyrene, and I'm going to use something that looks very similar to a piece of polystyrene, but it's made of wheat. It's a wheat pellet. Now, you might not have these things. You might decide to choose something else. You might want to expand your experiment. You might want to test a blob of blue tack. You might, instead of one of these, have some instant coffee. So you can choose items apart from what I've got here. Just depends what you've got available. Now, when we're testing, we need to make sure we use the same amount. So I am going to use a spoon, but I'm going to use a new spoon for each item so that it doesn't contaminate at all. And I'm going to do a level spoon like we did with the salt in the first experiment. So you need to use something that's flat, like a pop stick or perhaps a plastic knife, so that you can make it a level teaspoons by leveling off the top. Because if it's a heaped teaspoon, it's very hard to get that to be accurate, and exactly the same for each cup. So I'm going to do my experiment. I'm going to have a guess and say Nesquick. I think that will dissolve, because I've seen that happen when it goes into milk before. So perhaps make a list in your discovery diary. Grown-ups, you can help with this. What do you think will dissolve and what do you think won't dissolve? And then you can do the experiment. So I'm going to test all my things, but perhaps you should pause the video because I want you to test yours and predict without seeing what's happening with mine. Now, how did you go with your results? I got some expected and some unexpected results. I thought the Nesquick would dissolve, and everything, once after I put them in, I gave them a stir, so it was the same conditions, and the Nesquick did dissolve really well. Now, I thought that the Milo would dissolve because I've seen that go into milk before and it dissolves, but I realised, because not all of it did, that I've seen it go into hot milk before, but when it was going into something that was cold, the cold water, it didn't dissolve nearly as well. So there's another thing I could try. If I got a bit of water from the warm tap, what would happen then? But the grown-ups need to help you with that if you're going to explore that further. So my Milo was unexpected because I thought it would dissolve like the Nesquick did, but it didn't. Now the sand I didn't think would dissolve, and mostly it didn't. The water's gone a bit cloudy, so some of it has dissolved, but not very much. And the sugar, I thought the sugar would dissolve, but there's still a bit down the bottom there that hasn't dissolved, so perhaps it's a bit like the Milo. It dissolves in hot drinks like tea, but not so well in cold water. Now the polystyrene piece is floating on the top and hasn't dissolved at all. That was what I expected. And the wheat pellet doesn't look like it's done very much yet, but I actually think it's getting smaller. So we might come back and have a look at that in a minute and see if it does dissolve a bit more. I think it's just going to take a bit longer. As I stir it here, I think it is actually getting smaller. So which of your results were what you expected? Which of your results were unexpected results? Did you try something different like blue tack or coffee? Talk to your grown-up about what results you had. So now we've learnt a bit about measuring water very accurately and looking at what can dissolve in it. Water is a really useful thing to have on our planet because so many things can dissolve in it, and it means that we've got water in our blood which dissolves all the things that our cells need, and we use water in lots of places to transport things that are dissolved inside it. Now I'd like you to go back to the questions at the start. What do you think you know about water? What do you think you know about water now? Have any of your ideas changed about how useful water is and whether we can mix things in with it and how you actually use it? Are there some things that you thought of how you use water? Perhaps you thought, I drink it, I cook with it, I wash in it, I put flowers in it. What other things have you thought about how you use water? Now we've got a couple of extra activities for you to do as well. The first one is asking, will it soak water up? So I'd like you to go around your house or garden and gather up some things. Perhaps you're going to choose a piece of paper towel, or you might choose a placemat, or you might choose the kitchen sponge, or you might choose a spoon. And you're going to drip some water on it, so you might use your pipette or syringe or straw, and you'll drip some water on it and see if it soaks the water up or if the water runs off. But before you do, remember, make a prediction or have a guess about what you think is going to happen. So that's the first one, will it soak water up? The next thing is to go on a water or a liquid hunt around your house. So look at all the places where there are liquids or water, and you might be surprised where there is liquids and water everywhere around your house. The next thing we're going to do is, because we're talking about measuring accurately, we're going to do some measuring, and I'd like you to use some kitchen scales perhaps. There we go, got it to turn on. To do some measuring, and you might choose some things and you might line them up. Okay, looking inside my Milo tin, it's pretty full. I think this would be the heaviest, so I'm going to put it at that end. Looking inside my Nesquick tin, it's a bit emptier, but it's a larger tin. Maybe it will actually be the heaviest one. And then here's my sugar. How much sugar have I got? I think I've got less sugar than I have Milo, so I think it will be next. And then I might choose something like my timer. I think that'll be the lightest thing. And then actually use your kitchen scales and do some weighing to see which is the heaviest thing, and did you get them in the right order, or did you get an unexpected result? So that's another little extra activity you could do. And then the final extra activity is to make a tornado in a bottle. Now, if we were doing this face to face, we'd give you a tornado tube to use, and you can see I've got 2 soft drink bottles, some coloured water in one of them. They're both connected into each other by the tornado tube. When I turn it upside down and I give it a little bit of a spin, we get a tornado happening inside there as the air spirals up through the middle and the water goes around down the outside. Because this bottle is now full of air, this bottle has got water in it, and they want to get back to this spot when we turn them upside down. So the water's trying to get down, the air's trying to go up. At the moment it's just bubbling, but if I give it a spin, I can actually get a tornado happening as the water and the air swap places. Now, because we haven't got a tornado tube to give you, we're going to find a different way to make our tornado in a bottle. So you need 2 bottles the same size. So I've got these 2 smaller ones, and I might just use some newspaper in case I spill. So I need to put some water in one of the bottles. So you could just do this at the tap, but I'm going to demonstrate it here. So I'll use a funnel to pour some water into that bottle. Now you can leave it clear, colourless, or you can add a colour to it if you would like to. That's up to you. You need to be careful though with this food colouring, because it will stain if you get it on your clothes. It will stain if you get it on your hands as well, but it will wear off from your hands, but it won't wear off from your clothes. Okay, so I've put about 3 drops in. Give it a bit of a swish. Now, because we haven't got a tornado tube, if you just so happen to have one of these washers, you can use it. If you don't have one of these washers, you can manage without it. So if you had a washer, you would just sit that there and then put this bottle on the top. If you haven't got a washer, then you're just going to sit this bottle on the top. Now, the next bit is attaching them. And if you have got waterproof tape of some sort, so you might have, this is waterproof bandage tape that I got from the chemist. This is electrical tape, waterproof electrical tape that you can get from the hardware store. Now, if you haven't got either of those, then just use some sticky tape or some masking tape, but it won't be waterproof, so you'll have to keep retaping it and it'll probably leak. All right, so what I need to do now is to tape my two bottles together, try and get the first spin around really tight. So go to the top, go down around the bottom. Okay, so now we're going to try and see if we can have a tornado in the bottle. But before I'm going to actually do it over a container, because just in case this is not waterproof. All right, so turn it upside down, give it a spin, and there we've got our tornado happening. And our tape has held up. So that worked really well. But you might want to always do your tornado tube over something or at the sink or on a surface that it doesn't matter if it spills onto. Because remember, if this food coloured water drips onto the carpet, you probably won't be able to get that out. So that over the carpet is not a good place to try this experiment. Okay, so there's 4 extra activities to try. Make a tornado in a bottle, do some weighing of things, go on a water or liquid hunt, and test what soaks water up and what water runs off from around your house. Okay, so that's the end of our session about wonderful water and measuring accurately. Hopefully you will be more aware of where water is, why it's such a special resource, which we're actually going to get to in the next session, a bit more about why water is so special. And when you get the chance, try doing some accurate measuring. Now, we haven't actually talked about doing much recording in our discovery diary yet, so you can perhaps make a picture of your what dissolves experiment. And how is my, speaking of which, how is my wheat pellet going? Oh yeah, it is definitely dissolving. It's slow, but it is definitely dissolving. So this is a good packing material that, unlike the polystyrene, which doesn't dissolve at all, that will actually dissolve away. So you might do some drawings of what dissolves. You might do some drawings of what soaks up water or where you find water around your house. Okay, see you next time.